So what we're going to discuss for the next couple of classes is reaction types. So not just how to write a reaction and how to balance it, but also to put it into a category. The first type that we'll discuss is a formation reaction. And just so everybody knows, another way to say formation is synthesis. So take a moment, write down the description of formation, write down the example, and then we'll do the example together. So we have formation. The definition or the description of formation is that two elements combine to make a compound. I'd like to even add a little thing here. Sometimes it's more than two elements, not always, but it can be. The key thing is that I start with elements and I end up with a compound. And so I'm pointing that out because recognizing what you start with and what you finish with is a good way to distinguish which category of reaction we're discussing. Anytime your reactants are elements, the most probable thing that's going to happen is that they will combine. Now I'm saying most probable because of course there are exceptions, but we're not going to focus on those. We're going to focus on the most probable thing. In the example, I've indicated to you that sodium and chlorine are going to react. So we'll start out by writing those two things down. Now sodium has Na as its symbol. I would not write a number next to it. It's an element and it's not on that list. And even if it hadn't said solid right here, I would know that it is because of the color coding on the periodic table. Now my solid sodium is going to react with chlorine gas. Chlorine is an element, and it is on the list. I have no brighter, clever friends, so I put a 2. Even if it hadn't said gas in the question, I would know that it's a gas because of the color-coded legend on the periodic table. Now look at something that's new. I didn't tell you what the product is going to be. And so one of the things that we're going to practice is predicting what will happen by knowing what type of reaction is occurring. Since in this reaction I have an element and another element, the most probable thing that will happen is that those two elements will combine to make a compound. So what will it look like when they combine? Well, one of them is a metal and one of them is a nonmetal. That means when they combine, I'm going to have an ionic compound. And so I ask myself, what would this ionic compound look like? Well, it must be the result of sodium and chloride ions coming together. Anytime I think about an ionic compound, I think about the charges. Sodium is +1, chlorine is -1. So when I swap and drop, what do I get? NaCl. Notice that I didn't write NaCl2. Just because chlorine has a 2 when it's an element does not mean it's going to have a 2 as part of a compound. When things are elements, the only way you would write a number is if they're on the list. When they're in a compound, especially an ionic one, you care about charges. That's how we determine things. Since this is ionic, I have to say that it's solid because there's no indication that I put it in water. So now I want to balance my reaction, which we've been working on already. So I ask myself, on the left, what do I have? Well, I have 2 atoms of chlorine, 1 atom of sodium. On the right, I have one of each. So earlier someone asked me, is there a trick to remember to add things up? Making a little tally like this might be helpful when you're counting how many atoms you have. Now, since I don't have the same number of chlorine atoms on both sides, my first step is going to be to add a coefficient 2 here. Doing that, increase the number of chlorine atoms to 2, increase the number of sodium atoms to 2 as well. So I have to come back and add a number 2 there. Now that I have 2 of each thing on both sides, my reaction is balanced. So realistically, what's new here is that you recognize you have an element and an element making a compound. Now that's not the only way I could ask you about formation, and so my other example is designed to show you a different way I could word the sentence, but still be asking you about formation. So take a moment, write down the other example. The other example says magnesium carbonate is formed. Now in this example, magnesium carbonate is formed. I didn't tell you anything about what I started with. All I told you is what the product was. So in this case, magnesium carbonate is ionic. I know that because magnesium is a metal. So I would look up the charges. Magnesium is 2 positive, carbonate 2 negative. Now, seeing as how they have identical numbers but opposite signs, I know that those charges will cancel out. I don't even need to use swap and drop. I would simply write MgCO3. I knew it was solid because ionic compounds are always solid. Now here's what I have to determine. I produced a compound, one compound, and we'll see that the only kind of reaction we're going to study where only one compound is the product is a formation reaction. So my deduction would be that I had some elements that made it up. Now you'll notice I wrote the word element 3 times, and that's on purpose. That's because I can see that I have Mg, magnesium, C for carbon, and O for oxygen. I have 3 elements in my compound, so I must have used 3 elements to make it. So when I'm writing the formula for elements, I don't care what the charges are, I only care, are they on that list? Magnesium is not. I would simply write Mg solid for magnesium. Carbon is also not on the list. I would write C solid for carbon. Oxygen is on the list. Oxygen always has a 2 when it's an element. So I would write O2 gas. These are 3 individual elements, so I would put pluses in between them. Notice I didn't write O3 just because I had a 3 next to oxygen at the end. I wrote O2 because when oxygen is an element, that's the number that goes with it. Now my last step is balancing. If you got a question? Carbon is not, it's a solid. If you look at the periodic table, the color coding, you'll see that it's part of the, I think it's green ones that are non-metals that are solids. Now if we continue, if I count, I currently have 1 magnesium and 1 carbon on each side, but I have 2 oxygens here versus 3 oxygens over there. So my oxygens are not in balance. I will balance those first. The lowest common multiple of 2 and 3 is 6. So if I were to multiply by 3 over here, I would get 6. And if I were to multiply by 2 over here, I would get 6. Now on the left, I only affected oxygen, but on the right, I affected my whole compound. So now I have 2 magnesiums and 2 carbons. So I need to come back to my reactant side and add some coefficients so that I now have 2 magnesium and 2 carbon atoms on each side. All right, I'm just going to bring everybody back together for a minute so that I can make a couple of comments. My first comment is about 14F. In 14F, it doesn't say which charge for nickel you're using, and when you go to look up nickel, it has 2 possible numbers. So if that happens, it is always the one on the left that's the more common one. So for nickel, in its box on the periodic table, it says 2 positive, 3 positive. I picked 2 positive because it was on the left. It's the more common one. And that would be true anytime we don't indicate which charge it is we're supposed to be using. Now I will bring this screen with the answers back up in just a couple of minutes. What I do want to show you guys today is the reaction that's the opposite of formation. So we'll be following the same basic principles, but we'll be going backwards. So I'd just like to do with you 2 examples of decomposition, and then you can have the rest of the time after that to keep working on questions. So I'm going to switch back to the notes. I'll bring these answers back up as soon as we're done doing these other 2 examples. So I would just like to tell you guys about decomposition. Please take a minute and write down the description for decomposition. All right. So the description of decomposition is that a compound breaks apart into 2, or like we saw before, sometimes more, elements. And the first example says that water has electricity passed through it to decompose. Now, electricity isn't a substance, it's energy. And so we won't write electricity. The same thing would be true for heat or anything like that. They're not actual substances. So when we're talking about decomposition, I know that I'm going to start with a compound and end up with a couple of elements, maybe more. So a decomposition reaction looks just like formation, but written the other way around. In a decomposition reaction, our compound, in this case water, comes first, and my individual elements will come second. And so the steps would be the same. I see the letter H, I write it at the end. I see the letter O, I write it at the end. And then I ask myself, do either of those 2 elements have a number when they're alone? And the answer is yes. They both have a 2. They're also both gases. And so this would be my unbalanced decomposition reaction. H2O liquid converted to H2 gas plus O2 gas. Notice that I did not look at the numbers in the formula for water when I asked myself how I write out hydrogen and oxygen. I put 2s because they're on the list. Now I balance. I notice that I have 2 oxygens and 2 hydrogens here, 2 hydrogens and only 1 oxygen there. So my first step is to balance oxygen. This big number 2 tells me to multiply both of those by 2. It balances oxygen, But now it added some more hydrogen, so I have to do the same thing to hydrogen on the other side. That would be the balanced decomposition reaction for water. Now that's a simple example where I just had two elements. My other example is something that has a polyatomic ion, because I'd like to say something about it. When sodium sulfate decomposes, that means that sodium sulfate is my reactant, and then I'm going to have some elements as my products. A very common mistake that people will make is to not write elements as the products, and I'll show you what I mean. Sodium sulfate is Na2SO4. I know that because sodium is +1 and sulfate is -2. So when I swap and drop, the 2 from sulfate goes next to sodium. Now it says that it's decomposing, so I know that means I'm breaking my compound down into elements. That means I'm going to have Na, I'm going to have S, and I'm going to have O. Notice what I did there. Even though sulfate is one polyatomic ion, when I do decomposition, I don't care anymore. I always break things down into each individual letter. So I did not write, for example, that my products were Na and SO4. And I'll tell you that is the most common wrong answer that people would give, is they would not split SO4 up into elements. Now in my products, sodium is a solid. It's not on the list, so there's no number. Sulfur always has an 8, and it's a solid. Oxygen always has a 2, and it's a gas. My initial substance, my reactant, would be a solid because it's an ionic compound. Would anybody like to ask any questions about just the formulas before I balance this? So to balance this, we got to start with the biggest number, and the biggest number is sulfur. So if I count, I have 1 sodium, 8 sulfur, and 2 oxygen on the right. And if I count, I have 2 sodiums, 1 sulfur, and 4 oxygens on the left. Now, all of them are out of balance, and I'm saying start with the biggest number because it will make your life easier. I'm going to start with sulfur. There's 8 on this side, only 1 on the reactant side. So I'm going to put a coefficient of 8. Now that means that instead of 2, I have 16 sodiums. Instead of 1, I have 8 sulfurs. And instead of 4, I have 32 oxygens. So now I compare that to my products. I just balanced sulfur, so it's okay. I only have 1 sodium here, so if I add a coefficient of 16, I will have 16 sodiums. For oxygen, I have 2. If I add a 16 there as well, I will have 32, which is what I'm looking for.